Hello third year, welcome to today's lesson on conductivity of substances. Today we are going to be discovering which types of substances conduct electricity and which don't. By the end of the lesson, you're going to be able to tell me whether a substance can conduct electricity or not, and explain why it does or why it does not conduct electricity. Now first of all, just to clear a few things up. Electricity is the flow of electrons, and the conductivity of a substance is its ability to allow electricity to pass through, to allow those electrons to flow through. If a substance conducts electricity, it must have freely moving charged particles such as electrons or ions. So a quick recap, electricity is a flow of electrons. In order for electricity to pass through a substance, for a substance to conduct electricity, that substance must have freely moving charged particles such as electrons or ions. So, before we move on, can you think of any substance that conducts electricity? Can you think of any substance that does not conduct electricity? So consider these two substances in your head. You've got in your left hand you've got the substance that conducts, and your right hand you have the substance that does not conduct electricity. What type of bonding do you think is present in your substance that conducts? And what type of bonding do you think is in your substance that does not conduct? Think about it. Make a decision on the bonding you think is in each. And we'll move on and we're going to test to see if you are right. So if we were doing this in the lab, we would set up a circuit like the one shown below with a light bulb and a battery pack, and we would test different substances to see whether they conduct electricity. Now, this circuit we've set up is incomplete. Our substance that we are testing will be put in this gap to complete the circuit. If that substance conducts electricity, the light bulb lights up because we have a complete circuit with electricity able to flow all the way around. If the light bulb does not come on, that means that this substance does not complete the circuit because it does not conduct electricity. So unfortunately, no, we're not in the classroom. So we're not actually going to ask you guys to do this at home. What I'm going to do is I'm going to play a short video and I'm going to talk through exactly what's happening in it. So here we go. Now, what we can see here is a light bulb connected. I'm going to pause it. Oh, maybe not. I'm going to restart it. Apologies. Okay, so in front of us we have a light bulb, and these wires will be connecting it to a battery pack or a source of electricity. Now, electricity is going to flow through, and it's going to flow down through one of these electrodes here. Now, these electrodes are not connected. Now, because these are not connected, the circuit's incomplete, so our lamp is off. In order to complete the circuit, we've got to connect these electrodes with a substance that's going to allow electricity to flow through it, like this metal desk. So once the electrodes are placed on the desk, electricity is able to flow through the wire, down the electrode, across the substance or through the substance, up through the second electrode to power the light bulb. Now what we have here is a range of different solids, and we also have distilled water here. So on this side we have distilled water. When we talk about distilled water, it's pure water. There's no minerals or ions dissolved in there, it's just pure H2O. We then have aluminium shavings here. We have C12H22O11, which to you and I is just sugar. We've got sodium chloride, some table salt, and we've got silicon dioxide on the far right. So let's allow the gentleman to pop his electrodes in and we'll see if the circuit is complete. In this case, the only light that came on was the one for aluminium. Let's have a think about bonding here before we move on. So, water would be an example of covalent bonding. That's hydrogen bonded to oxygen. That's a covalent bond. Aluminium is held together by metallic bonds. C12H22O11, so sugar. Carbon is a non-metal. Hydrogen is a non-metal. And oxygen is non-metal. So this means there's covalent bonding here. So far, our metal has conducted electricity. Our water has not. And our sugar, which contains covalent bonds like water, has also not conducted electricity. Now the next one along sodium chloride is an ionic substance. Sodium being a metal, chlorine being a non-metal. When they come together to form sodium chloride, they form an ionic bond. This is also not able to conduct electricity. Last one on our video here is silicon dioxide. Now silicon dioxide, that is again two non-metals. It's a covalent bond, but it is slightly different to sugar and to water in that where these two covalent substances are covalent molecules, silicon dioxide forms one of those huge covalent networks. It also does not conduct electricity. So here's what I am seeing so far. We'll see how this goes in the next bit. Solid metal conducts electricity. Solid covalent compounds do not. Solid ionic compounds also do not conduct electricity. My only conductors so far are my metal shavings. Let's move on. So what he's doing is he is adding water to these solutions. So we've cut the water out, we're not doing anything more with that. We are now taking distilled water and we are adding it to each of our solids. Now, as we should know from a previous lesson, our metal is going to be insoluble, which means it's not going to dissolve. Our sugar, which is our covalent molecule, is going to dissolve in water. And so is our ionic compound, sodium chloride. That's going to dissolve too. And our silicon dioxide, which is our covalent network, should not dissolve. And there we go, as predicted. Now, let's see how they behave with the light bulb in. So this time around, the only light bulb that is on, or has come on, the only circuit that is complete, is our sodium chloride. So what we've seen here is our ionic solid doesn't conduct electricity, but an ionic solution does. Our sugar and our silicon dioxide are still not conducting electricity, so covalent solids, covalent solutions do not conduct electricity. Water is a covalent liquid. It didn't conduct electricity. So far, no covalent compounds are conducting electricity at all. Now, aluminium, which lit up in the last test, when it was just the aluminium shavings, that lit the bulb and completed the circuit. But this time, when we've added water to the aluminium, the light bulb is not coming on. Now, the reason for that is that because our distilled water doesn't conduct electricity, what it prevents is the electricity flowing through at all. So even though the aluminium has the ability to conduct, because it is submerged in water, that water acts as an insulator. It prevents the electricity from flowing between the electrodes and completing the circuit. So quick recap, sugar and silicon dioxide, which are covalent compounds, do not conduct electricity as solids or in solutions. Remember, silicon dioxide is not dissolving at all. It's still not conducting electricity. Our ionic compound, sodium chloride, will conduct electricity in solution, but not as a solid. And aluminium, or metal, conducts as a solid, but will not conduct underwater, because water is an insulator. Let's continue on, see what he's got planned for next time. Okay, so this time around on the far left we have a hydrocarbon here. Hydrocarbons are substances that are made only of hydrogen and carbon. Here we have ethanol, which is the alcohol present in most alcoholic drinks. Being made of carbon, hydrogen and oxygen, it is a covalent compound. Copper is a metal. Calcium chloride is an ionic solid here. And copper sulfate is also another ionic solid. So let's see how they get on. So as we saw the last time, our covalent solid does not conduct. Our covalent liquid does not conduct. Our metal solid, or solid metal rather, does conduct. And our ionic solids do not conduct electricity. Now you've seen it before, you're going to see it again. He's going to take his electrodes out and he is going to add water. Now, why he's adding water to the ethanol, I will never know because it's already a liquid, but you know, to each their own, let him batter in. And we can see that this time, as with before, our covalent liquids, our covalent solutions, are not conducting electricity. Because the water is insulating the metal in here, it cannot conduct electricity anymore. However, our ionic solids, which have dissolved in water, are able to conduct electricity now that they are in solution. So, what should you take from this? So what you should have realised then is that covalent substances do not conduct electricity. Ionic substances do not conduct when solid, but they do conduct when liquid, molten, or in solution. Now, molten is when you heat a metal to the point where it starts. So what should we take from this then? So covalent substances do not conduct electricity whether they are solid or liquids or in solution. Ionic substances, on the other hand, will not conduct when solids, but they will conduct when they are liquid, molten, or in solution. This is because the charged particles, in this case the ions, are able to freely move in a liquid, melt, or in a solution of ions. Metals are able to conduct electricity as solids and as liquids. This is because they have freely moving charged particles, but in the case of a metal, it's the electrons that are freely moving. Now, I'm not going to leave it there. I'm going to explain it in a bit more detail. So why do metals conduct? So what I have in front of us right now is a diagram that represents a metallic bond. So in metallic bonding, metal atoms lose their outer electrons. So the furthest away electrons become delocalized. They don't belong to any particular atom anymore. And those atoms, because they've lost electrons, become positive ions. Now, each positive ion is attracted to a pool of these negatively charged delocalized electrons, but within the bond, the electrons are free to move throughout the structure. So because they're not attracted to just one ion, they can bounce from side to side, top to bottom, all the way throughout your metal. Because these electrons are free to move from one end of your substance to the next, that means metals are able to conduct. They have charged particles, and those charged particles, those electrons, are free to move. So what about ions? Why do ionic compounds conduct only as solutions or melts? So what you've got on the screen in front of you is an example of an ionic lattice. Now, in an ionic lattice, positive and negative ions come together in a really uniform way. All your negative ions will be surrounded by positive, all your positive ions will be surrounded by negative ions, and they form a very tight, compact lattice structure. They're packed very tightly, and so these ions, although they are charged particles, cannot move. Because they cannot move, that flow of electrons, that is electricity, cannot move through the lattice structure. However, when we dissolve an ionic lattice, an ionic solid in water, what happens is the ions, although they are still very much attracted to each other, they separate out. So they're not as tightly packed together anymore. The lattice is broken down, the ions are further apart, and because they are further apart, they are now able to move and carry charge. They can carry that electricity from one end to the other throughout the substance. Ions in a molten state can move and conduct electricity. And if we melt an ionic compound, we also separate the lattice out, we partially break it up, and that allows them to move because they're not held so tightly together, and it allows electricity to flow through the substance. So metals conduct as solids and melts and liquids. Ionic compounds can't conduct as solids, but they can conduct in solutions, in molten states. But again, not as solids. The reason they can conduct in solutions or in the molten state is because we have separated the lattice, we've broken it down slightly. The ions aren't as tightly packed together, they are able to move. So what about our covalent compounds? Like in metallic bonds, there are electrons involved in covalent bonds. So why can those electrons not carry electricity like in a metallic bond? The answer is very straightforward. If we look at our diagram here of a covalent bond, these shared electrons are held tightly in place through their attraction to the nucleus of their own atom and the nucleus of the atom they are being shared with. Now, because these electrons are so tightly held in place, they are not free to move, and therefore they cannot conduct electricity. Okay, so let's consider water. Now, when water is in the form of ice, which is a solid, in one ice cube we have hundreds and thousands of H2O molecules tightly packed together in the one space. So let's imagine that each of the tiny circles, and is this a good drawing? No. But let's imagine for a moment each of these tiny circles are one molecule of H2O. Now, what happens when the ice melts and becomes liquid water is that these H2O molecules, remember, each of these is one molecule of H2O. When ice melts, the water molecules space further out. Now let's go back very quickly to what I said before. In a covalent compound, these electrons are not free to move, so we cannot conduct electricity. Even though when we melt ice down to water, the water molecules separate out, there's more space between them, the electrons that are being shared between hydrogen and oxygen are still stuck in these bonds. There's no free electrons to move. So whether it is a solid, whether it is a liquid, the electrons involved in covalent bonds are tightly held up in those bonds, and therefore they cannot conduct electricity. So, to summarise, metals always conduct electricity. Covalent substances never, ever, ever, ever conduct electricity, with the exception of graphite. Graphite is a special form of carbon, and it's the only covalent substance that can conduct electricity. So covalent substances never conduct electricity unless we are talking about graphite. Ionic substances conduct when molten or in a solution, but not when they are solid. In order to conduct electricity, you must have freely moving charged particles. Only substances with freely moving charged particles will conduct electricity. Okay, so here is your job now that the lesson has reached the end. On page 10 of your notebook, now the notebook is either going to be in files or you should have, if you've gone into school, a physical copy of these notes. On page 10, there is a table, exactly like the one on the screen just now, and you are going to fill it in. You are asked whether the substance is ionic or covalent. Top tip from Miss McPherson here, get your data booklet out. You want to be looking to see whether the atoms involved in each of these compounds are two non-metals or a metal and a non-metal. So I'll start you off. So in hexane, carbon is a non-metal, hydrogen is a non-metal. Two non-metals bonded together, she's going to be covalent. The L beside hexane, L is for liquid, so its physical state is liquid. You're going to tell me whether it conducts or not. A covalent liquid, do you think it conducts or not? Right, yes or no? Sodium chloride. Chlorine is a group 7 element, so that's a non-metal. And sodium is a group 1 element, it's a metal. So metal, non-metal, that is an ionic substance. S is for solid. So we have an ionic solid. Does it conduct? You tell me, yes or no. Remember, metal and non-metal is ionic bonding, two non-metals, covalent bonding. You are going to fill out this table on page 10. You are then going to complete the blank spaces below the page. And you are going to upload in the assignments tab an image, a scan of this document, of this piece of paper, to show me that you've done it. I will be uploading it also as a Word document page, so if you would rather do it as a Word document, you absolutely can, but I advise you to have a physical copy of this whole note booklet, whether you've got the physical copy just now or you're filling it in as an electronic Word document, and we can organise printing it out when we're back in school. So in case I haven't said it often enough, this table is on page 10 of your pupil booklet. Fill it in, fill in the missing words beneath the table as well. There is also going to be a 10-question quick quiz, it's multiple choice, to test your knowledge on this lesson. So you have 2 assignments to do for this one. Get them done, get them turned in, and we will get feedback to you as quickly as we can. Thank you very much for going through this lesson with me. Thank you for your attention. Thank you for your patience with me. And I will see you all in the next one. Bye guys.